The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. So today we're going to go on to section 6.2, which is factoring trinomials with a leading coefficient of 1. But before we do that, are there any questions you'd like me to look at from last night's homework? Alrighty, and I didn't get any emails to that effect, so we will go on to section 6.2. So before we look at factoring trinomials, I want to look at multiplying polynomials together because we're going to basically be undoing that situation. So if you took Math 85 or perhaps a beginning algebra class somewhere, you hopefully looked at this process. But let's say we've got x plus 2, the quantity, times x plus 3, the quantity. And we're going to multiply those two binomials together. So we get x squared plus 3x plus 2x plus 6. Sometimes we refer to this as FOIL, F-O-I-L, as in first times first, and then outer, and then inner, and then last. So first, outer, inner, and last. Let's see, does outer have two T's? Outer, I don't know. Anyway, okay. So then going on, combining like terms, we get x squared plus 5x plus 6. So multiplying together these two binomials, we get this trinomial, that is with 3 terms. Let's look at another example. Let's say I've got x plus 5 times x minus 2. So I get x squared minus 2x plus 5x minus 10. Combining like terms, x squared plus 3x minus 10 is my final answer. Any questions about that process? Okay, so now let's take x squared plus 5x plus 6, and let's pull it apart into two factors, both of which are binomials. So basically, we're going to take this problem and go back the other direction. Well, where does this come from? That comes from the first times the first. So x squared would be split up x and x. Okay. Where does this come from? This comes from the last and the last. So that means this number times that number has to be 6. So we're looking for two numbers who have a product of 6. Okay, well, let's see. 6 and 1, 3 and 2, negative 6 and negative 1, negative 3 and negative 2. Those are all a pair of numbers, two numbers whose product is 6. All right, but where does this come from? Well, that comes from the inner, this times this, and the outer, that times that. So the inner and the outer, or for all you Australian soccer players, oi, okay, they like to say that. So it comes from the inner and the outer. Now, that means that this plus that has to be 5. So we need a sum that is 5. So we're looking for a pair of numbers whose product is 6 and whose sum is 5. Well, if you look at these pairs of numbers, this one has a product of 6 and a sum of 5. So those are the two numbers that are going to go in to complete the two sets of parentheses. And sure enough, x plus 3 times x plus 2 That's what we started with up there. That's going to give us x squared plus 2x plus 3x, which is 5x plus 6. So we're looking for a product that is this number and a sum that is that coefficient. Let's take a look at another example. Let's say we've got y squared plus 4y plus 3. So we have a trinomial, and I want to point out that it's in what's called standard form or descending powers of the variable. We've got y squared, then y, and then no y at all. Also, we have a leading coefficient of a 1. So I'm going to split this up. The y squared is going to get split up with a y and a y. It's the first term of each factor. We're looking for two numbers whose product is 3 and whose sum is 4. Well, let's see. 3 and 1. Oh, 3 times 1 is 3. 3 plus 1 is 4. So there they are. Plus 3 plus 1. And if we FOIL that back together, we get y squared plus y plus 3y plus 3, which is y squared plus 4y plus 3. So the solution checks. Any questions about this example? Okay, let's take a look at another problem. Let's say we've got n squared minus 7n plus 10. Again, we have a trinomial, that's 3 terms. The terms are in descending powers of the variable n, and the leading coefficient of the first term is 1, or an implied 1. So we're going to split it up with an n and an n. We need a product that is 10 and a sum that is -7, okay? So the product is this number, the sum is the coefficient of the second term. Well, let's see, what gives us 10? 10 and 1, 5 and 2, -10 and -1, -5 and -2. Oh, well, to get a negative sum, it couldn't be either of those anyway, could it? So it ends up being what? That? -5 times -2 is +10. And -5 plus -2 is -7. So we get -5 minus 2. I want to go back for a minute. I could have saved myself some writing. I could have looked at this and said, okay, to get a positive product, I've either got to have a positive times a positive or a negative times a negative, right? Positive times positive is positive. Negative times negative is positive. But if you have like a positive and a negative, their product is not positive. So the two numbers have to both be positive or both be negative. But you can't add two positive numbers and get a negative sum. So what that tells me, now that I've gone through that discussion, is right from the get-go, I'm looking for two negative numbers. So I would only consider those two possibilities. Any questions on that? All righty. Let's see here. M squared plus 2m minus 48. So we're going to split this up, starting with an m, starting with an m. The product is -48, and the sum is a +2. Well, again, let's consider the signs. We're looking for a negative product. So to get a negative product of two factors, you've got to have a positive and a negative, or a negative and a positive. So basically, you've got to have one of each. One positive factor, one negative factor. Okay? So we don't have two positives, we don't have two negatives. But our sum, in this case, is a +2. So if you're going to add two numbers, one positive and one negative, and the result is going to be positive, that means that the positive number has to have a larger absolute value than the negative number. It's got to be more powerful. So my positive number has to be bigger. Well, let's see. So I could have 48 and -1, 24 and -2, 12 and -4, 6 and -8. what did I do? Where did I get those pairs? Well, I just started sort of on the outside and I cut this in half, so I doubled that. I cut this in half and I doubled that. I cut this in half and I doubled that. But let's see, this gives me a sum of 47. This gives me a sum of 22, a sum of 8. Oh, a sum of -2. I've got the right number, but the wrong sign. How about 8 and -6? Now, the process I went through was kind of lengthy. If you were able to see those two numbers right away, you don't need to write all that down. But if you aren't, this is a way of getting there, working your way towards the finish line, so to speak. So we're going to have a +8 and a -6. That's going to give me m squared minus 6m plus 8m minus 48, combine like terms, m squared plus 8m minus 48. So it checks. So this would be the correct factoring of this trinomial. So we're taking a trinomial and factoring it into two binomial factors. Okay, again, any questions on this example before we're going on? All righty, let's take a look at this problem. A squared minus 10a minus 39. So we're going to split this up with a's at the front. The product is negative and the sum is also negative. So just like the last example with a negative product, we've got to have a positive factor and a negative factor. Oh, but now the sum is negative. So that means the negative number is more powerful than the positive number. So how about -39 and 1? Well, I can't cut -39 in half, but I could take a 3 out and I get -13. If I divide this by 3, I'm going to multiply that by 3. So basically, there's another pair of factors whose product is -39, but the sum is -10. Any questions there? Now, a question that you might have is, does it matter which order I put these two in? Could I have done it like this? And I think we talked about this a little bit yesterday, that multiplication is commutative. So by taking the two factors and switching the order, the result is still going to be the same. Okay. All right. Here we have a trinomial that has a leading coefficient of a -1. We want our leading coefficient to be positive before we go on and factor it in the process we've been doing. So the first thing we're going to do here is to factor out a -1, which in effect changes the sign of each term in the parentheses. Now I'm going to take that quantity in the parentheses and factor it. But I've got to remember this -1 is still there. So I'm no longer considering this. I'm now looking at this one. So the product would be a +20. The sum would be -9. To get a positive product, I need two positive factors or two negative factors. But to turn that into a negative sum, I've got to have two negative factors added together to give me a negative sum. So how about -5 and -4? Would that do it? Yeah. So -5, -4, and there's my final answer. Again, any questions? All right, I'll just keep continuing. If I'm going too fast, let me know. I can slow down. Otherwise, I'll just keep putting examples out there. All right, here we have a squared plus 6ab plus 5b squared. So my leading coefficient is a 1. I've got an a and an a. The product is 5 and the sum is 6. The product is positive, so I've got to have two positives or two negatives. The sum is positive, so they've got to both be positive, 5 and 1. What about that? 5 times 1 is 5. 5 plus 1 is 6, so I've got +5 + 1. Well, there's a problem. I have a second variable in this trinomial. I've forgotten all about the b squared. Well, how would the b squared be broken up at the end? We'd have a b here, and I'm going to take this and write b there. I could write 1 times b, but the 1 isn't necessary. So I'm still dealing with the coefficients, but I've got to have an a in the front and a b at the end. Let's see, that would give me a squared plus 1ab plus 5ab plus 5b squared, which is a squared plus 6ab plus 5b squared, and it checks. Okay. Let's see here. Let's take a look at this one. P squared minus 7pq plus 10q squared. I should have mentioned this on the previous problem, but I'll mention it here. This trinomial is in standard form in terms of the variable p. In fact, let's go back here. This trinomial is in standard form in terms of the variable a. We've got a squared, a, no a at all. It's not in standard form in terms of b, but it is in standard form in terms of a. This one is in standard form in terms of p. So we'll have p and q at the end. All right. The product is 10. The sum is -7. Product, sum. To get a positive product, I need 2 positive factors or 2 negative factors. But if I have 2 positive factors and I take those numbers and add them, I can't get a negative sum. So I'm looking for 2 negatives, -10 and -1, or -5 and, oh, there it is, -5 and -2. So -5 minus 2. Let me rewrite that. P minus 5q times P minus 2q. All righty. Okay. Here we have 3y squared minus 21y plus 18. Now, this is a trinomial, and it is in standard form, descending powers of y. However, it doesn't have a leading coefficient of a 1. It has a 3. But notice 3 is the greatest common factor of all 3 terms in the trinomial. So kind of going back to section 6.1, I'm going to factor out that greatest common factor, leaving me with y squared minus 7y plus 6. Now I've got a trinomial with a leading coefficient of a 1, so I'll split that up. My product is 6, my sum is -7. Notice I'm looking here, not up there, okay, to get my 2 numbers over here. So positive product, 2 positive factors or 2 negative factors. Negative sum, got to have 2 negative factors. How about -6 and negative? Oh, there we go, -6 and -1. I could have also written these, but that would give me a sum of -5, which is not correct. So -6, -1, and there we have the answer. All right. Let's see here. -m cubed plus m squared plus 56m. So again, we have a trinomial. It's in standard form in terms of m cubed, m to the second power, m to the first power, so descending powers. Our leading coefficient is not a 1, it's negative. Not only that, but there's a common factor of an m. So I'm going to factor out -m so that my leading coefficient inside is positive. Let's see, that's going to be what? -m and -56. Let's see, that would be -m cubed plus m squared plus 56m. Okay. So then I'm going to take the trinomial and split it up. My product is negative 56, and my sum is negative 1. Recall that negative m, the coefficient would be negative 1. There's an implied 1 there. Okay. So now my product is negative, which means I need a positive and a negative factor. Okay, positive and a negative. But when I add those together, I get negative 1. That tells me a couple of things. That tells me that the negative number is slightly more powerful than the positive number. And the fact that they're slightly more positive, it's slightly more positive, those two numbers are very close together, but one is positive and one is negative. So think about 56. Think about your times tables. What times what is 56? 7 times 8. Well, what about a 7 and a negative 8? That would give you a product of negative 56 and a sum of negative 1. If you know your times tables well, this is going to go a lot faster than if you're having to rely on a calculator to figure out how to pull apart 56. Okay, it's never too late to keep working on those if you need to. All right, let's see here. Y squared plus 100 plus 25y. The directions here say write each trinomial, in descending powers of one variable and factor it, or put it in standard form. So the first thing I'm going to do is rewrite it in descending powers of the variable y. Okay. There is no greatest common factor, and the leading coefficient is a 1. So now I'm going to break it apart like that. The product is 100, and the sum is 25. The product is positive, and the sum is also positive. That means I'm looking for two positive numbers. Well, let's see. I could start at the outer region and say 101. 100 times 1 is 100, but the sum would be 101, right? So that's not right. But I could take 100 and cut it in half, consequently double the 1. 50 times 2 is 100, but that would give me a sum of 52. Well, I can cut this in half and double that again, and I get a product of 100 and a sum of 21. Let's see here. Oh, the sum isn't 21. What's the sum? It's 29. That's what was wrong. So I'm getting closer and closer to 25, aren't I? So it seems though I need a number smaller than 25 and a number larger than 4, whose product is 100 and whose sum is 25. How about 20 and 5? Now, again, I spent all this time looking for it. If you could look at it initially and see that in your head and go, oh, it's 20 and 5, you don't need to do all this other stuff. But I'm just trying to give you a method of getting there if you don't just see it right away. So this is plus 20 and plus 5. Any questions there? Alrighty. Let's see here. A cubed plus 5ab squared plus 6a squared b. Well, this is a trinomial, and there's a couple of variables there. It's not in descending powers of a, and it's not in descending powers of b. However, look here, I've got a cubed, a to the first power, a to the second power. So I could write it a cubed plus 6a squared b plus 5a b squared. So now it's a cubed, a squared, a. It's in descending powers. Oh, every term contains an a. That's the greatest common factor in this case, isn't it? So a times a squared plus 6ab plus 5b squared. So now my product is 5 and my sum is 6. positive product, I need two positive or two negative factors. The sum is positive, so I need two positive numbers. 5 times 1 is 5. 5 plus 1 is 6. So I'm going to have A, and then I've got an A. Oh, I've got B's at the end, right? And this is plus 5 plus 1B. Now, I put that 1 there to emphasize it came from there, but I don't need to put the 1, oops, in the answer like that. In fact, if I'm remembering correctly, in WebAssign, I think if you put a 1 as a coefficient where it's not needed, it doesn't recognize it and it marks it wrong, even though technically it's not wrong, but just be careful with that, okay? So if you've got a 1 coefficient, you don't need to put it, it's implied. All righty. How about this one? V squared plus 9V plus 15. So here we have a trinomial. It's in standard form, descending powers of V. There's no greatest common factor. It has a leading coefficient of a 1. So we're going to break it apart with a V and a V. And the product is positive 15. And the sum is positive 9. So now we're looking for two numbers whose product is 15 and whose sum is 9. Well, the product has to have either two positive factors or two negative factors. But if we add two negative numbers, we can't get a positive 9 as a sum. So we're looking for two positive numbers. Let's see, 15 and 1, 5 and 3. Those are the only, integer possibilities. And here we're using integers as our factors. Well, 15 and 1, that would give me a sum of 16, and that would give me a sum of 8. Apparently, there aren't two numbers whose product are 15 or is 15 and whose sum is 9. So that means this thing doesn't factor. So we say that it is, prime. Or we could say it's a prime polynomial. You can just write prime or say prime polynomial, okay? Meaning it doesn't factor. All righty. Let's see, let's take a look at another one here. R squared minus 9R minus 12. We have a trinomial in standard form in terms of the variable R. There's no greatest common factor we can take out, and the leading coefficient is a positive 1. So we'll break it apart with an R, and the product is negative 12, and the sum is negative 9. To get a negative product, we need a positive number and a negative number. To get a negative sum, the negative number would have to be the larger of the two. So how about negative 12 and 1, negative 6 and 2, well, it couldn't be that one because the larger number has to be negative. So negative 4 and 3. None of those add up to negative 9, do they? Again, this is prime. All righty. Let's see here. We're going to look at some problems that are kind of a mixture of problems from 6.2 as well as 6.1. This says AB plus B plus 2A plus 2. 4 terms. Typically, when we have 4 terms, we use factoring by grouping. First of all, though, let's see, there isn't a greatest common factor of all 4 terms, is there? So let's split it up into 2 groups of 2. The greatest common factor of the first 2 terms is B, and the leftovers are A plus 1, which means the leftovers on the second group should be A plus 1 if I'm going to get this thing to continue. And sure enough, if I take out a plus 2, I can get plus 2A plus 2, so that works. So now the next step, taking out the greatest common factor and the leftovers, we get A plus 1 times B plus 2. Let's check our work. Let's FOIL them back together. AB plus 2A plus B plus 2. Let's see. AB, check. 2A, check. B, check. And 2, check. So there's the final answer. And let's see here. 40c squared minus 12c. Well, this is a binomial. It's got two terms. Let's see. There's a greatest common factor. Let's see here. 40 is what is 40 is what? 2 times 2 times 2 times 5. And 12 is 2 times 2 times, oh, 4. I can take out a 4, but I can also take out a c, can't I? So 4c, which would give me 10c minus 3. Let's see, that's 40c squared minus 12c. And there's no common factors here other than a 1. So 4c times the quantity 10c minus 3 would be the final answer. Okay, let's see here. 3xy minus 3x plus 15y minus 15. Well, we have 4 terms, so grouping is probably the way to go. But before I do that, I see that there's a greatest common factor of all 4 terms. Can anybody tell me what it is?
3.
Excellent. Okay, so we'll take out a 3, which gives us xy minus x plus 5y minus 5. Now I'm going to use factoring by grouping. So I'm going to switch this over to brackets, and I'm going to get x times y minus 1. So over here, I'm going to have a y minus 1 and a plus 5 outside, and that gives me what I need here. So I've got 3 times the quantity y minus 1 times the quantity x plus 5. And there you go. Let's see here. How about this one? 3a to the 4th power plus 30a cubed plus 75a squared. Well, this is a trinomial. It's in standard form. Oh, there's a greatest common factor. I can take out a 3 and I can take out an a squared. So what's left? I've got a squared plus 10a plus 25. And I'm going to split that up further if I can. I'll have an a and an a. And the product is 25 and the sum is 10. Positive product, 2 positive or 2 negative factors, positive sum. So I've got to have 2 positive numbers. How about, let's see, 25 and, oh, 5 and 5. Okay, 5 times 5 is 25. 5 plus 5 is 10. So plus 5 plus 5. All right. So there's my answer. Since I have 2 identical factors, I could also write it like this by taking this and combining it as x plus 5, the quantity squared. So either way would be a correct way of writing it. Okay, let's see here. Let's take a look at this one. Negative 3a plus a squared plus 2. What's wrong with this problem?
It's not in descending power.
Correct. So we'll rewrite it. A squared minus 3a plus 2. I'm going to break it apart with an a, and the product is 2, and the sum is negative 3. Positive product, 2 positive or 2 negative factors, negative sum, got to have 2 negative numbers. How about negative 2 and negative 1? There you go. Minus 2, minus 1. All righty. I think I've tortured you enough for one day. So I will be back this afternoon at 1:15 for my office hour. If you have any questions, I'm going to go ahead and stop the recording,